Okay, so today we are going to learn about squares and square root functions. Okay, how the graph of f of x is equal to x square and g of x is equal to square root of x related. So let's learn. First of all, we're going to learn about f of x is equal to x square. So if x is equal to minus 3 x square, y would be equal to x is equal to, so it would be like this. If x is equal to minus 3, so y would be equal to minus 3 square, which is equal to 9. 4 1 0 1 4 9. So let's plot this. Okay, it's minus 3, so it would be 9. Minus 2, so it would be 4. Minus 1, so it would be 1. 0 1, so it would be 1. 2, so it would be 4. And 3, so it would be 9. So this is something that we will get. Okay, g of x is equal to square root of x. So now if x is 9, 4 1 0 minus 1 minus 4 minus 9, so square root of x would be 3 2 1 0. Square root of negative number does not exist, does not exist, does not exist. So the graph we're going to get is, for 9 it would be 6 7 8 9, it would be 3. For 4 it would be 2. For 1 it would be 1. For 0 it would be 0. For minus 1 it would be nothing, because minus 1 does not exist. The graph is going like this. This point is called the vertex point. So this is the graph of f of x, and this is the graph of g of x. So if we restrict the domain of f of x is equal to x square to 0 to positive infinity, then what will happen? F of x and g of x are inverses. Okay, cubic and cube root functions. F of x is equal to x cube, g of x is equal to cube root of x. Okay, so let's take x is equal to 0, negative 1, 2, negative 2, 3. 0 cube root, negative 1, cube of negative 1, cube of 2, cube of negative 2, 27. Okay, 0 graph is going in this direction. 0 1 negative 1 8 negative 8 0 1 negative 1 2 negative 2. Okay, so this is the center, Okay, and in this case f of x and g of x are inverses. So if we have the cube root, then cube and the cube root are inverses of each other, and square root are not inverses of each other. Square and square root are inverses of each other in case we restrict the domain of the square function from 0 to infinity. Okay, now what is absolute value function? Absolute value function will make the negative numbers to answer in the positive way. All negative numbers will answer in the positive way. Okay, so 0, 1, 1, minus 1 will also give the answer with positive 1, minus 2 with positive 2, plus 0, 1, 2, 3 with positive 3, negative 3 with positive 3. So absolute function is going to go in this direction. So the graphs of the absolute function make a perfect V-shaped graphs of absolute function. And what is axis of symmetry of absolute function graphs? X is equal to 0. Now these are the graphs of some common parent functions. Linear graph is in this way: y is equal to x, where y is equal to mx plus c, where what is m? M is the slope, and this is the y-intercept. Quadratic function is y is equal to ax square, where a means shape of vertical reflection or vertical compression over x-axis, and h and k means the vertex. Cubic function y is equal to x cube is the cubic function, where a means shape, vertical reflection, vertical compression over x, and h and k means center or vertex. Exponential function means a means the shape or the initial value which we need to take to make the function exponential, initial value, and h and k will be the new x and y axis. Logarithmic function is a is the initial value and hk is the new x and y axis. Absolute value function is the shape or the slope, hk is the vertex. Square root function. Square root function a is the shape, vertical reflection, vertical compression over x-axis. hk is the vertex. Cube root function is the shape, vertical expansion, vertical compression over x. hk is the center or vertex. Reciprocal function is a 1 over x minus h plus k, where h and k is the vertex and a is the vertical. Okay, now we have to do some exercises which are based on the functions that we have already learned. Follow these steps to write the equation for the graph of g of x. Identify the type of function. So which type of function is this? So we know that this function is of type cubic. This is cubic function x cube. What is the transformation equation for this function? Okay, so what is the cubic function? Cubic function is a function y is equal to a x minus h whole cube plus k. So the main equation is y is equal to a x minus h whole cube plus k. Okay. Identify the vertex or center and we write the equation using these h and k values. What is the vertex and center for this equation? The vertex and center for this equation is this one, which is 4 from the x-axis and minus 1 from the y-axis. So we can write this equation again as y is equal to a x minus 4 whole cube minus 1. Point, pick a point other than the vertex or center and use this to calculate a. Okay, let's take this point. This is 5, 6 from the x-axis and 1 from the y-axis. Okay, now using these 2 points we can find a. Okay, y is equal to, sorry, the point was 6 and 1. 1 is equal to a 6 minus 4 whole cube minus 1. So a is equal to 1 by 4. Now we can rewrite the equation as y is equal to 1 by 4 x minus 4 whole cube minus 1. Come to the next exercise. For each graph below, identify the type of function and then write the equation. Now which graph is the first one? This is going like this. So this is a square root function. Now what is the equation for the graph of the square root function? Square root function. Y is equal to a square root of x minus h plus k. So the graph should be y is equal to a square root of x minus h plus k. What is h and k? The center point. Okay. Or the initial value. H and k are the initial value or the center point. So it's -4 and -6. And what will be a? We need to take 2 points. Let's take this point, 0 from the x-axis and 2 from the y-axis. Okay, so it would be okay. This is a cubic function, and the graph of the cubic function can be written as y is equal to a x. You need to learn the equations of all the graphs. Cubic function is a cube root of x minus h plus k. Okay. This is the center, so this is -3 and 2. Okay, so which function is this? This is absolute value function. Okay, what is the equation for the absolute value function? Y is equal to mod of x. Y is equal to a x minus h mod plus k, where a is the slope. Y is equal to, sorry, y is equal to a mod of x minus h plus k, where a is the slope. So what is the slope over here? It is moving to rise by 1 1 2 3 3. So m is equal to 2 by 3, which is rise by 1. So it is equal to 2 by 3 x minus h plus k. What is h and k? H and k is the vertex, that is plus 3 minus 6. Y is equal to 2 by 3 x minus, so 2 by 3. Okay, what is this graph? This graph is now cube root graph. Okay, so it is y is equal to a cube root of x minus h plus k. Okay, what is h and k is the center value, and that is this one minus 1 and plus 4. Y is equal to a cube root of x plus 1 plus 4. Let's take another point, for example this one, 6 7 7 5. Okay, so it would be 5 is equal to a okay. Consider the function f of x is equal to, just identify the vertex or the center. What is the vertex? H and k. So x minus h, so vertex x minus h minus 4. Create a table of values, use numbers that you can take the square root of. Plot the point and connect with a smooth curve, clearly showing the end behavior. Minus 5 minus 4 minus 4 minus 1 minus 1 plus 2 plus 4 plus 5. Consider the function g of x is equal to this. Identify the vertex. Okay. Consider the function minus 3 by 2 x minus 4 minus 1 mod function. So the vertex is 4 minus 1. You do not need to table the values of an absolute value graph as long as you know how to graph slope or rise over run. What is the slope of this function? 3 by minus 3 by 2 is the slope. Minus means reflection and 3 means rise and 2 means run. So 3 means rise. What is the slope of this function? Minus 3 by 2. So 4 and negative 1. 4 and negative 1 is the vertex. And we're going to go in the opposite direction because there is a sign of negative. 3 means 1, 2, 3, 1, 2, 1, 2. Then 1, 2, 3, 1, 2, 1, 2, 3, 1. Plot the vertex from the vertex, rise down 3 and run to right point. Put a point. Go back to the vector down 3, 3, run point, and we will draw V like this. Sketch the graph for the function. This be clever about the numbers you select for your table of values. Include at least 3 significant points, including the vertex and the center. So first of all, we should know what is the vertex and what is the center. Okay. So vertex in the center is 3, 2. Okay. If I will put 3, 3 minus 3 would be 0 and you will get the answer 2. So next you can put 4, 4 minus 3 would be 1, 1 by 2 plus 2 would be 2 whole 1 by 2. We'll put 2, 2 minus 3 would be 1. And again you will get 1 whole 1 by 2. If you will put 5, you will get 6. If you will put 1, you will get minus 2. 3, 2, 4. Recall that to find inverses of a function algebraically, you need to switch x and y and then solve for y. Find the inverses of this function. So we need to switch y is first of all we will write y is equal to 2 x plus 4 ka whole cube minus 6. Now we are going to switch x and y. Now we are going to solve for y. Okay, let's do the next one. Let's switch x and y. Okay. When do you need to restrict a domain of the inverses? when the function is not one to one. In this function, we need to restrict the domain of the inverse, because if I will put 3 over here, it will become 0. So the domain should be restricted to 3 to positive infinity. So when we're going to restrict the domain, when function is not one to one, quadratic or absolute value. In quadratic functions and absolute value functions, we need to restrict the domain. Okay, use the function composition to verify the functions are inverses or so on. So using function composition is easy. It is f g of x, which is equal to f, what is g of x? Cube root of minus x minus 2 plus 3. This is g of x. Okay, so now we're going to put it in f of x minus, we're going to put x minus 3 cube plus 2. So what you're going to get is minus x plus 4 gf of x. Df of x g of x cube root of minus x so not inverses because they are not equal to each other. Okay, problem number 6.1, write the equation for each of the following. A cubic function shifted 5 units down. So what is a cubic function? X cube. So y is equal to x cube minus 5. An absolute value function, okay, reflected across the x-axis, it means y is equal to a negative sign, vertically stretched by a factor of 2, shifted to the right and moves up. A square root function vertically compressed by a factor of 1 by 4, shifted 2 units to the right and 7 units down. For each graph, we'll identify the type of function and then write the equation. Okay, type of function, this is a cubic function, and the graph, this is the center, this is 1 and minus 4. Cubic function can be written as y is equal to ax minus 1 ka whole cube minus 4. Taking another point, let's take this one, 2 and minus 2. So it would be minus 2 . which one this function is. This is a square root of x. Initial value is 3, 2. This function, cube root function. This is cubic function and this is cube root function. Okay. So the center point is this. If we will take this point, this is 4 and 6. This is absolute value function. Okay, so absolute value function was y is equal to m x minus h plus k. So what is m? Rise over run 1, 2, 3, 1, 2, 3 by 2, and it's in the opposite direction. X minus h. What is h? This is minus 3, 5. Okay. Graph each square root function showing at least 3 significant points. So for graphing the function, we need to find the values of x and y. Okay, let's take 4. 4 minus 4 is 0, so we will get 3. We will take 5. 5 minus 4 is 1. 1 plus 3 is 4. We will take 8. 4. 8. 8 minus 4 is 4. Square root 2. 2 plus 3 is 5. Okay, write an equation for the function f of x graphed here. This is a square root function. So it would be ax minus h plus k. Okay, so now to find the value of a, we will put 5 0. 4 2. Okay. We need to find the equation of F inverse x algebraically. So we can write it y is equal to 3 by 2 x minus 1 minus 3. And we can do it like this. We need to switch x and y. Now, because this is a square root function, so we need to restrict our domain, that is minus 3 to 4, minus 3 to positive infinity. Graph each cubic and cube root function showing at least 3 points. Okay, now we need to graph the cube and the cube root functions. For graphing, we need to take the values of x and y. Okay. Graph each absolute value function showing at least 3 points, significant points. Okay, so absolute value function, the main thing for absolute value function is this 5 by 2, and it's 3 and minus 4. So it's going to be happen that, okay, so it is minus 3 and minus 4, and it will go in the upper direction too. Okay, find the inverse algebraically, restrict the domain if possible. So this is a cube root function, so we're going to write it y is equal to cube root of x minus 4 minus 2. Now we're going to change the x in the y, switch x and y. Okay. Use function composition to verify whether or not the following functions are inverses or of each other. So for using function composition, we need to find f g of x. Now we're going to put it in f of x. Now there is some extra practice for you. For each function showing at least 3 significant points, draw the graph. For f of x is equal to minus 2 x plus 3. So let's see this. Write the equation for each of the graph. Now the graphs are given, we just need to write the equation. It is very simple that we have already done. This is a cubic graph. Center is minus 3 0. So y is equal to minus x plus 3 ka whole cube. This is square root, and it is 4 6. So y is equal to minus x minus 4 plus 6. This is cube root, and it is 0 minus 2. So y is equal to a cube root of x minus 2. So finally we are done with these graphs. Thank you.